Okay. Good morning, gentlemen. Good morning. So we are starting index laws. So the first lesson is introduction, and I'll tell you why these laws work the way they do, and then we'll do some easy questions applying those laws, and then we'll do some difficult questions, but we'll do it next lesson. Okay, so you have done this in year 8? But you don't remember? Yes, so that's fine, but you have done it, right? So when we write A and then there's a number on top of it, how do we say that? How will I read that?
AM.
AM. How will you do that?
A to the power of
A to the power of M. Are we happy with that? Yeah. Yes? Have you heard of that before?
Yes.
Perfect. So when we do A to the power of M, A is called the base. And what's M called? Power. Any? Yep. And? Yeah, indices or index. What else?
Exponent.
Yes, index or power. And it's also called the exponent, but that's not a commonly used word. Okay? So we'll be calling it power or index, and that is why this topic is called indices. We're talking about where a number, which is the base, has an index. Is that clear why we call it indices? Yes?
Yes.
Okay, now what happens if we have the same base? So we have a number to the power of m times the same number to another power, right? For example, if I have 2 to the power of 3 times 2 to the power of 4. Is that similar to this rule? Yes? What will it equal? Let's do that. So what does 2 to the power of 3 means? That's prior knowledge. You should know that. So if I raise something to a power, what does that mean? You've done this in year 7 and year 8. So if I have 2 to the power of 3, what does that actually mean? Does that mean 2 times 3? No. What does that mean?
2 times 2 times 2.
Exactly. That means this number, which is the base, is multiplied by itself this many times. Does this make sense? So the base was 2, so that means 2 will be multiplied to itself. How many times? 3 times. So what would 2 to the power of 4 be?
2.
3 times.
Happy with that? So that's what the power means. Any questions so far? Okay, now, what happens when we have the same base, but the powers are different and the numbers are being multiplied? So I'm going to write, this is the index form, and this is the, what do we call this? Expanded form. So 2 to the power of 4 is the index form, and this is the expanded form. Right? Now, I'm going to write 2 to the power of 3 as expanded form. So 2 to the power of 3, can I write it as 2 times 2 times 2? Yes? Now, using a different color, I'm going to write 2 to the power of 4 as expanded as well. It's too light. 2 times 2 times 2 times 2. Is that right? Now, because the base is same, what's the base? 2. How many times in total have we multiplied? 7. So can I write that this is equal to 2 to the power of 7? Yes. So what do you think the shortcut is? Rather than doing this, what would you do here? Because you don't know what m and n are, what happens to the powers? They get added. And that's where our first index law comes from. Because we had 2 to the power of 3, so we wrote 2 times 2 times 2. Then we had 2 to the power of 4. So we have 7 now. 2 is being multiplied by itself 7 times. So this is equal to 2 to the power of 7. So can I then write that if the bases are same and they're being multiplied, the powers are added. Does this make sense now? Yes?
Yes.
Perfect. So let's do this one. How would you do this question using the knowledge that you've just gained? 3 and 3, is the base same?
Yeah.
That is really important. Can you see in all these laws the base is the same? At least the first 3. Yes?
Yeah.
If the bases are same and they're being multiplied, what happens to the powers? They get added. So the powers will be 5 plus 4, which is 9. Now you're not supposed to find out what 3 to the power of 9 is. I don't want you to waste your time doing that 3 times 3 times 3 then 3 and figure it out. This is a genuinely valid answer. Is this making sense?
Yeah.
Great. Next one. Now we have division. What happens when we have, let's say, a number? Give me a base. Any number for
7.
7. And then we have another base. But the powers are different. So give me a power.
20.
20. Okay, give me something smaller that I can fit on this
8.
board. 8. And then give me another power.
2.
2. Alright, now let's see what would happen here. 7 to the power of 8. Can I write it in expanded form? How many times will I multiply 7 by itself? 8 times. So 7, 2, 3, 4, 5, 6, 7, 8. Is that right? And then in the denominator, 7 to the power of 2. So 7 times 7. Is that clear so far? Now, this divided, 7 divided by 7 is 1. 7 divided by 7 is 1. Or in other terms, we say they cancel out. Does that make sense? How many 7s are we left with? 6. So can I write this as 7 to the power of 6?
Yes.
What happened to the powers? What's the relationship between these two powers and the answer? Exactly. Isn't 8 take away 2, 6?
Yes.
Yes. So can I then write a to the power of, now, in subtraction, order is important. Will I do m minus n or n minus n? So which power gets subtracted from what? Did we do 8 minus 2 or 2 minus 8?
8.
So what's 8 there? M. So this is important. Order is important in subtraction. So you always do power of the numerator minus the power of the denominator. Make sense? So how would we do it here? Is the base same?
Yes.
What's the base?
I.
A. They're being divided. So same base being divided. Powers get louder. Powers get
Subtracted.
subtracted. So power of the numerator, take away the power of the denominator, and answer is a to the power of 2. What's another way of writing a saying a to the power of 2? A squared. Well done. Happy with that? Alright, so we can prove the next ones as well. I'll let you have a go at that, why these work. So we're just going to do the shortcut. So what happens when we have a to the power of m and another power outside? What do you think will happen? Okay, let's just prove them, it'll be easier. So let's say I have 2 and then squared, right? Now this whole thing is squared, so can I multiply this whole thing by itself 2 times? Because I had 2 to the power of 3 but I squared it, so I have to multiply 2 to the power of 3 by itself, right? And now bases are same, powers will be, they're being times. What happens when they're being times? Powers are added. So do we get 2 to the power of 6? Isn't that 3 times 2? Yes or no?
Yes.
So when you have this, it becomes mn or m times n. Okay? When you have a times b, so for example, if you have 2 times 3, let's say to the power of 2. So that means you have 2 times 3 multiplied by itself, because you have 2 times 3 squared. So 2 times 3 times 2 times 3. How many 2's do you have now? And how many 3's do you have? 2. So that means this power gets multiplied with the index of both. So you have a to the power of m times b to the power of m. What was a's power here? That'll confuse you. We'll talk about that later when we do complicated questions. Is that clear? Similarly with division, if you have a over b, see they're different bases now. And they've both been raised to a power of m. It's equal to a to the power of m over b to the power of m. Okay? So you have done all of these before, even though it doesn't look like. Let's go through the last one, and then we'll do some easy questions. What happens when there's something to the power of 0? What is that equal to?
1.
Raise hands if you think it's 0. Don't look around. Close your eyes. Everyone close your eyes. And now raise hands so we can't judge each other. Only I'll be the judge. Yep, raise hands if you think it's equal to 0. Alright, hands down. Now raise hands if you think it's equal to 1. Great, okay. It is equal to 1. Can someone explain why? So you know it's equal to 1, but do we know why? Alright, I'm going to use this law here, the second one, to explain it. Let's say I have 5 to the power of 8 divided by 5 to the power of 8. Now, are these the same things? So anything divided by itself is always equal to 1. Are we happy with this bit? Anything divided by anything divided by itself is equal to 1. Yes, what's 2 divided by 2? 1. What's 10 divided by 10? What's 5 divided by 5?
1.
What's 1,000 divided by 1,000? What's x divided by x? So it doesn't matter what you're dividing. If you're dividing a number by itself, it's 1. Are we happy with that? Now, if we look at the second index law, the base is 5 and they're being divided. Won't I minus the powers? Yes? So 8 take away 8. What's 8 take away 8?
0.
0. So can I then say therefore 5 to the power of 0 is 1? So I've just proved it to you. Anything to the power of 0 is 1. Does this make sense now? And that's what confuses most people. But here it is, why it's equal to 1. And that is the simplest way in which I can think of explaining. Other methods will complicate things and confuse you. Alright, let's attempt these 3 questions and I'll give you a little break and we'll do more complicated questions. Now, have a look at third law and tell me what will happen to the powers. So we have a number, a power, and then another power outside. What happens to the powers? They get times. So what will be the answer? B to the power of? 10. Right? Now, this question has a number part, so 8 over 12, and a pronumeral part. Again, numbers will be dealt with numbers, and pronumerals with pronumerals. 8 and 12, deal with them as you would in a normal fraction. Do they have a common factor?
Yeah.
What can they both be divided by? 4. 8 divided by 4 is? 12 divided by 4 is?
3.
So you get 2/3. Now, shh. We have the same base, x, and they're being divided. What happens to the powers if the bases are being divided? Subtracted. So can I say the power of the top one minus the power of the bottom? Yes or no?
Yes.
So what's 9 take away 5?
4.
4. That's your answer. Yes? What's anything to the power of 0?
1.
So won't n to the power of 0 be 1? Doesn't matter what n is. Then plus. What's p to the power of 0?
1.
1. And then it's simple. 1 plus 1? 1 plus 1? 2. That's it. Introduction to index laws again. So have a look. Let me know if you have any questions and then we'll use a mixture of these laws in a couple of questions. Okay? Copy that.